is effectively an exposure to local particulate emissions. Now, what shape do these emissions take? The most egregious, so there are different kinds of local air pollutants. The most egregious pollutant is what we call PM 2.5. PM stands for particulate matter, and 2.5 represents the size of the pollutant. So it's 2.5 microns. So if you want to kind of visually conceptualize what uh, uh, a particular particle looks like, is basically a tenth of a diameter of a strand of human hair. So if you take a human hair, a tenth of a diameter of a strand of human hair is what basically a PM 2.5 particle looks like. Now, there are millions or billions of these particles in the air. And then when you inhale them, our own system, our body isn't able to kind of filter out particulate matter, and it easily enters our bloodstream. And now
Yeah.
there's a lot of evidence that demonstrates that, I mean, this is both from like the economics literature, which is using a lot of observational data, plus a lot of the medical literature now that effectively demonstrates that the exposure to PM 2.5 leads to significant health effects. Now, these range from, aggravated asthma or bronchitis to chronic lung diseases. In the worst case scenario, perhaps even something like cancers, etc. Now, a new strand of literature, and a lot of economists have worked on this as well using observational data, is looking at the non-health effects of exposure. So for the longest time, we were kind of worried about the direct health effects, but now we have overwhelming evidence that exposure to particulate matter, to PM 2.5, have these non-health effects, and this includes an effect on cognitive ability. Students perform really poorly in school when they're exposed to PM 2.5. They're both short-term and long-term effects. So short-term effects would be short-term cognitive impact. So like if you're taking a test during a polluted day, your scores might be lower than compared to similar students, right? And similar students who are taking an identical test on less polluted days. So, it's now we have this wealth of evidence that exposure to PM 2.5 has, these drastic both health and non-health effects. So
So
this translates to significant costs, right? So health costs means that your burden of like picking up health tabs goes up, doing poorly on cognitive skills, including performing poorly on school tests, for example,
mm,
or on
mm.
tests in general in school, or performing poorly in school, then translates into these larger kind of like, problems with educational attainment that lead to impacts on future earnings.
So, speaking of PM 2.5, something that comes to my mind is uh, the unevenness in the experience that people have in terms of, I mean, as a layman, I do not understand what emits PM 2.5. Is it like specific types of fuels or is it like specific types of vehicles? And something that comes to
Mm,
my mind is like, why is there such unevenness? So, thinking about cities like Karachi, for instance, do not experience a lot of smog, but Lahore
mm,
does. So, is there like a
mm,
specific reason why particular areas would have more smog than others?
mm. So, particulate matter doesn't necessarily have to be emitted. Like even dust, small dust particles, if they're like smaller than 2.5 microns, can constitute as particulate matter. So, but mostly a lot of the PM 2.5 comes from combustion processes. So if you burn, stubble, crop stubble, for example, that's a big sort of source of pollution, especially in
Yeah.
the winter months in Punjab. And we can sort of, come back to that later and speak about sort of crop burning. But, farmers in both sides of Punjab, in Indian Punjab and Pakistani Punjab, they try to, they burn their rice stubble. And so that burning process creates these tiny, tiny particles. And they can be both solids or they could be like oily particles, or they have to be liquid in nature too. So, any combustion process leads to the formation of PM 2.5. In the winter months, the problem is that in places like Lahore, now geography also has a role to play in how much exposure that we get to PM 2.5. So if you live in a really windy city, you can have like PM 2.5 particulate emissions, but if it's really windy, the wind just basically blows the pollution away, right? But what happens specifically in places like Lahore or in Punjab in general is like in the winter months, we experience something called temperature inversion. Temperature inversion is a meteorological phenomena where there's a layer of cool air that gets trapped underneath a layer of hot air. So then you don't get a lot of air movement. So you have what we call like you're experiencing still air. So the pollution or the pollutants, these so PM 2.5 basically sticks around in the air. And in winter months, as the temperature goes down, a lot of the water in the air then condenses, especially in the mornings, and forms dew. And then when the PM 2.5 combines with this dew, it forms, it becomes much more visible. So in the winter months, Lahore and Punjab they often experience inversions, and that's why we see so much of smog in those months. In Karachi, on the other hand, you get a lot of sea breeze. So even though the emissions of pollution or the sources of there's perhaps if Karachi were to experience, this is of course, this doesn't happen in real life, it's a conjecture. But if Karachi were to experience inversions, the same amount of inversions that Lahore experiences, you'll be getting the same amount of smog or even worse smog in Karachi because it has the sources of emissions themselves in Karachi are larger than in Lahore. Now, related to your point, so here's the meteorological phenomenon why we observe smog. But related to your point, what are the sources of emissions? To get a good sense of what the sources of emissions are, we need to conduct what are called source apportionment studies. Source apportionment studies, you have environmental scientists who collect air samples, etc., and they get a good, and then often in like developing countries, for example, or developed countries, the environmental protection departments have scientists working for them who regularly conduct these source apportionment studies. But because of capacity constraints, et cetera, in developing countries, we often don't get these kind of studies. But what they do effectively is that they give you a sense of what the different types of pollutants are and what's the share of these pollutants in overall pollution, uh, and what those sources are, right? So you'll get a good sense of if you do a source apportionment study and you just look at PM 2.5, you'll get through these studies, you'll get a sense of what are the major sources of PM 2.5. So there have been these, so Lahore hasn't had we don't have any uh, source apportionment study to rely on to get a sense of what the different sources of pollution in Lahore are and what their contribution to overall emissions are. But there have been there's this remote sensing study done by the FAO back in 2018. And there's this recent study done by the urban unit in Lahore, which aren't exactly source apportionment, but they kind of sort of, try to mimic a source apportionment study. So everything that comes out of them should be taken with a grain of salt because there's a lot of imprecision, a lot of noise involved with the data that they collect and then the results that they produce. But these studies effectively demonstrate is that vehicular emissions is perhaps the largest source of particulate emissions in cities, followed by agriculture emissions in the winter, and then industry and power and the energy sector.